So it's been quite some time. So I literally just imported my values for V-bias3 and V-bias4 as DC sources connected to those things because I could not remember off the top of my head how to chain the things together. So I'll figure that out for later. But this is literally just using the same values as a completely different cell within that library. I don't remember it being hard. I was just working on other things. So if I simulate this guy, assuming it works correctly, it looks like it did. And then I move this damn thing out of the way. I'm going to add a trace that is just V out. And so it looks all wonky as hell. It looks wonky as hell because of the limitation of LT spice. So let me show you what I mean by deleting this really quickly here. Okay. So if I add V in 1, it also looks all wonky. The reason why it's looking this crazy wonky is because I'm adding a 1 millivolt signal on top of a 2.5 volt DC signal, and the resolution is jacked up. So to fix this, if we go to Tools and then Control Panel, and unfortunately there's not a way, at least that I've found, to save this. I'm going to make this 0, instead of 0.0025, 0.0001, hit OK, and resimulate it. Now I have a nice and neat sinusoid, which is what I would expect because I put a sinusoidal waveform in here. Okay.
Its simulation resolution wasn't dense enough to get all the data points.
Right.
So it looked like
that random, not random, but garbage. Yeah. So because we're trying to figure out what the small signal gain is here to make sure things are working well, what I'm going to do now is I'm just going to right click this signal and I'm going to subtract 2 from it. Or actually 2.5, because that's going to get rid of, actually, I take that back. Sorry, I'm going to delete this thing and now we're going to look at the output again. So what's the DC component of this? We expect that there is a DC component of the output voltage because our device is operating and carrying our currents and all this kind of stuff. So the DC output level of this looks to me to be 3.7175-ish. So if I subtract that DC value minus 3.7175, I get a nice output signal that's ranging from around -24 millivolts to +24 millivolts. When I plot V of V in minus 2.5 volts, sorry, V of V in 1, 2.5 volts, I can see that I have a voltage gain of about 22 to 23 volts per volt. I was too lazy to figure out how many decibels that is, but it's larger than 10, so it's greater than 20 dB, which is pretty reasonable for a single stage. I got that by setting my tail current to effectively be 2 10x2s in parallel. Okay, so it's a cascode configuration there. So I'm doubling my reference current and getting good gain. If I actually increase the number of copies, my gain is going to go down slightly. So this is kind of the sweet spot for the size for this particular technology node. If we make our tail current a cascode so that we have very large output resistance and about sized to give us about twice of our reference current, we maximize our voltage gain. And so from here, you just draw it. So draw it.
So I created,
Sorry, well, we're gonna be doing class stuff, like writing stuff down on Monday, just so that you're aware.
Okay.
And then probably go back to laying stuff out on Wednesday.
I'll read down one of my things.
Yeah,
I created 2 new cells that have bias practical, or I mean, no, so this is just your differential state, right?
yeah, so I just called it diff stage, I think. So tail current, current mirror, actual differential amplifier. Done so. Have any of you guys that are in senior design, so everyone excluding Stephen, not to exclude you or anything like that, actually turned in your draft yet? Your revised draft? I see a grimaced face on Sam, so that looks like a hard no for him.
Well, not yet, but we'll see if it gets done by the end of the day.
So the reason why I'm asking is because my end of the day and your end of the day might be vastly different things, because today is my 5-year wedding anniversary, so I hope to not stay here particularly late today.
Yeah.
I see.
So, I have a conference call that I'm gonna have to be on at 2:30 that I imagine will last somewhere in the ballpark of an hour-ish. So I anticipate leaving by 4 p.m. If you don't get it to me before 4 p.m., I won't be here to print it, and therefore I will not look at it over the weekend. I'll look at it on Tuesday, possibly Monday morning before class. But do that in a moment.
So other than just it's expensive, is there like a particular reason he likes it or?
They're like,
I haven't heard anything about it.
why would you, if you could get a Ferrari, why would you?
I would never own a Ferrari. Because
Oh,
you don't
yeah.
actually own them. You have a lease agreement. You try to do anything with it.
Oh, well,
It's easy.
yeah, that's just a Ferrari.
Also, I wouldn't want to work with a company that's so anti-consumer if I could avoid it, especially if it's voluntary. Now, if you're asking me, I would own a Corvega, but
How do you do that?
do
How do you draw a line if you don't have a right click?
I? There's gotta be a way to, okay, look at in your schematic layout, like at the bottom left corner, there should be some.
Okay, I see.
Yeah, I think that's
There's a wire.
you might be able to deal with that, but I
This is not going well.
do not know.
Well, oh, you know what I can do then? Sudo right click. No.
Because course, I'm cheap, so all the stuff I own is based on, oh, this is used and it's a good price. So I have, Smith and Wesson, which I kind of like that company because
Shields or.
I've heard that too, but mine is a MP9.
Very good.
It
A little
is.
bit that I've heard. Let's see, those are two things.
They are pretty good.
So I think this button. That.
Is it this? See, I haven't had any problems with it, but
I
you
don't have
have
a
to.
scroll. How do I pan around? Oh, wait, there's a button.
DC5. I don't remember what was the difference between shield and pickup, because I think it was capacity.
That's tough. I don't know. Let it go.
Years. Like certain live students say it's some sort of old school electronic device, they wouldn't know any better to tell me.
But yeah, it's a little generator. You spin the thing and it powers the light bulbs, but they replaced them with fluorescents a long time ago.
Yeah, but see, it doesn't do that because it's broken.
Back when they had Edison light bulbs in here, when they first came out. I bet every once in a while you could get somebody.
It's a pretty tough question.
No, I don't know why I always click that button.
What was the thing you did to make it not like a walk? Go to tools. Control panel. And then the relative tolerance, change that to 1, 0. Yeah. Okay. And then rerun the simulation. Now it's exercise. All right, thank you. Yep. So what's your output voltage? Let's well, I mean, if you use the same numbers that I did, then you're gonna subtract 3.7 175, I think. Yeah. Are those, so the numbers for V bias 3 and V bias 4, do they match what your circuit is? Yeah. Run your bias circuit. And then figure out what V bias 3 and V bias 4 are for what you've designed. And then use those numbers. They should be very close, but just for the sake of argument.
That's weird,
But that's probably just because I did the exact same numbers.
Right, so that's why you're getting literally an identical. That means you laid it out correctly.
This one.
Yeah, so run that one, and figure out what V bias 3 and V bias 4 are, and then set your numbers to those. Just 3 and 4. So those are the only two that you're using. Click on the signal. Yeah. 1.664. Yeah, and I have 1.678. So it's a little different. It's not gonna make a huge difference. 1.098 and I have 1.103. So yeah, so. Yeah.
I mean, mine's almost no different from yours from the, I went into the, I'm sorry, when I went into this and checked it for doing the two NMOS, it was almost identical to what you're getting on these ones. The only difference is 1.677, because I was checking this, it looks like the only difference in V bias 4, it's like 1.0289, so it's 1.03. Yeah, so it's almost identical.
Yeah. So if you get a sinusoidal output for a sinusoidal input and your gain's above 20, you're good. I'm actually rather pleased because I honestly couldn't tell you what I did different this year than last year, but last year the gain was 7. So threefold increase in the gain. Cannot figure out why, or too lazy to go watch the videos and figure out why it's better explanation. So if you guys want to play around with stuff over the weekend, what you could do is add a second gain stage to this, which would just be a common source, a PMOS common source amplifier. So you'd have a PMOS up here and an NMOS current source down here. There's really no practical reason why you would do a cascoded source unless you're going to do a cascode amplifier up here as well, because if you use a single transistor amplifier, the output resistance of that one is going to kill any benefits of cascoding the current source. And then the goal of that is to provide more gain, but also to move the DC biasing point more towards 2.5 volts for the final output stage. So if we went with an NMOS amplifier here, a PMOS current source, we'd be driving the DC state up closer to VDD. Going from an NMOS stage to a PMOS stage will tend to bring it back down.
I have my system pretty well figured out. You want to borrow my mouse for a bit?
You can figure out effectively whatever the maximum value of V out is your gain, since you're putting in a 1 millivolts.
Yeah.
Yeah, that's real high. Not remotely the same. I mean, that means your output is way, way up close to VDD, which means M4 probably isn't on. So all of the gates are tied. Yeah, the gate isn't tied there.
I haven't really ran.
Where's your spice code? No. So it's canceled. You have the right spice. Close this out. If you don't put the spice code on your figure first, it doesn't know where to look for the models and everything.
Okay.
So inside of here,
Right.
go to miscellaneous.
Right.
Yeah, and now you type in your spice code, and that tells LT Spice what to do.
Okay.
So without that, it doesn't know what model to use, and that's what that error was telling you. All right, so that seemed to fix it. Okay, good deal. At least I can troubleshoot.
Speaking of troubleshooting.
What'd you brush?
This over here, when I run this device, it doesn't give me the out, so I don't know. Do I have to name this now?
So I exported that as we Did you?
That's right, I didn't export it,
Here's what I found.
Shut up, watch. I had a picture of a buffalo. I don't know what that had to do. It's on wheels, the other one is not, and it moved much more easily. Yeah. That's where you put wherever, the next line is what you put wherever you happen to save the CFON files file, so I gave you guys.
Electric Electric doesn't like a lot of, but you know, it's free.
So if it's in program files, if you do PROGR_1, that tells it it's program files, and tilde2 is program files x86 or whatever, like you can get around that. If you know how to do some very minor old school DOS programming, which you guys probably most of you know.
I grew up using almost entirely old DOS computers and
Yeah.
had to learn how to do all of that jazz. And lots of DOS blocks after that. So.
Okay, now that I did the proper thing. That should be fine.
Honestly, that's slightly more enjoyable than trying to go through.
there's C5 is literally just a big text, so just save that as a text file.
Tools. No simulation, no. What did he say?
Go to preferences. Yeah, okay, and then in preferences,
I
usually,
usually, hold on,
yeah, hit the hammer button. Okay, so the
now
first
you
window
have your
compression,
desktop.
go down to where it
So
says
that'll be
relative tolerance.
relative tolerance.
colon
change.
slash users slash whatever
And then rerun.
the username is slash desktop
Like,
slash
delete it.
C5.
No, well, you,
Oh, I hit run.
yeah, you just hit run again. It'll recalculate with no tolerance.
You should be able to literally copy and paste that application.
Yes.
Oh, yeah. you-
Much better, still a little. Now I need to.
Hit okay. Go back to
Like
it.
also. Oh, there. It's weird, I can't see it in here no more.
I've already messed. What Okay.
Oh, sure. So how do you-
Slash C5 underscore models. TXT.
Minus 2.5.
Okay. Now, run, see what happens. Okay. So for MM3A, hit cancel here. Close this up. Sorry.
How am I supposed to plot these?
Upside down.
Oh, okay, sorry, that's your, that's me.
I think I am.
So I think I roughly have that right, but the gain on that looks a little aggressive. It might just be the scale.
That's roughly what he had. Okay, so. And you have them centered in 0. So I need to do VN minus 2.
Sure, I did V in one,
Yeah.
and then V out, I just did minus 3.1, or 7 ones at the top, because that his numbers are on, so that 0.29.
Yeah.
All right, where is electric on this thing? I want to run it. Yeah. This thing? All right.
I think so. Although I'm having some difficulty intuitively understanding the gain on, I know it's 0.98. If I just did that, yeah, I would be in this game, that's not right, because it's done this 22 times. So this is a basic understanding of that. Well, that just seems pretty high to me. This gain would be 22.87.
And don't forget, there's also that team and self-evaluation due today. For 406.
That's actually so the decimal gain would be 27.18. Taking the 21 ratio voltage
Behaving as if it cannot find the model, which means behaving like it's not including the stock include statement. Which I do not have choice. If I tell it to include it, it should include it.
This offset is not find efficient for whatever reason. Spice model.
Yeah, it's saying that it can't find the link.
You did 20 times the volume base 10.
20 times along, base 10, 22.8757 gives me 27.2.
I also don't know why it's saying that it is a length of 100 microns and a width of 3 microns, when that's very much not what it is. That's right here. The length is 0.6 microns. I can't know. Perhaps people are small, so that I also quite fine, so check that. So, hours off. That 82 cents. Yeah, so that's 2.5 volt offset, 1 millivolt amplitude, 1 kilohertz frequency. Yeah. Why is it not recognizing models? Why is it saying that they are 100 microns long? But is recognizing.
The spice parts and mine's spice parts. Spice part.
That's for that. And the loss of science even here. setting up T lines to that. We'll have to go to. Or, option right, and what this would be. them. And, um, Did not care for you doing the first time with you license, but there. Did not. Much. That's what is. All that seems right. Just for the sake of argument.
Like, whatever you're supposed to do.
Still way higher. Not really, but it doesn't know what the hell is happening here. Which is good. But now, it's, there we go. It wasn't treating, it wasn't applying the right voltage at that time. All right, so. In the other voltage, minus 30 points. Okay, it works out. I don't know what you were doing. But now it works, so to do it more like me, not knowing what I was doing.
Yes, sir.
I honestly don't know that it matters, but stop putting them upside down.
Okay.
And then make sure that when you're doing these exports, so it's hard to see, but there's a little plus sign right there. That's what you're exporting. So with that thing connected, the clicked, that's what you control your export.
Gotcha, okay.
I don't think you necessarily even need the whole tag.
No.
I think you just put that the.
If you just have a pin, you can export it that way. This is for doing things off page, which, when I remember how to do it, will allow you to effectively stage things together and wire them. Okay, so, but anyway, okay, all right, it works. We're cleaned up. Yeah, awesome. What was wrong with it ish?
So that's how I put the 0 volts, 5 volts. Anyway, well, it was that V-3 wasn't at the 0. I was thinking maybe it's something above it that's not connected, but no, there was nothing connected to V5 except for these things. That was I had to.
Right, so there should be one feedback, yeah.
Yeah. And putting that there fixed everything.
That'll do it.
Yeah.
Okay. Good deal. And then, yeah, you're really close. That's awesome.
Yeah.
That's fantastic. Have you measured your currents through any of your reference transistors or anything like that to see how they compare? If the voltages are that close, I would assume the currents are going to be very
I
close. as
haven't
well.